Hello again, welcome back to Sailboat Building video series. This time we're continuing with additional test with the laminated frames. And that's why I have this fine spruce board here. It should be pine, but I couldn't find pine at this point. But this is very fine piece of wood. And what we are here in this dark attic is this bandsaw here, what I bought last fall with a very cheap price. So cheap that with that price you could basically buy a new cord for it. So it was almost free. And this thing is huge. It weighs maybe 600 kilograms and it is industrial machine and it's fully functional. So this is going to be very important tool for me, I guess. And now I'm gonna try to use it for the first time to cut strips from these boards. So this should be 70 millimeters wide. Yep, I'm gonna put 6.5 millimeters plywood on either side. So this is a bit too wide, but I think for this test it's okay. But the idea anyway is to make a full-size test piece and yeah, let's see how this thing performs. I don't know if that blade in there is good, but I have plenty of new blades that came with it, which are all more expensive than the whole thing was for me, so that's good. Yeah, let's try this out. Alright, after a bit fiddling, here is some new strips for the lamination. So I did a couple of different thickness. This is maybe 3 millimeters. It's very bendy. This is maybe 4. It's much more stiff. And there is a couple of very thin ends like these. These should be good as those wedged pieces between there. Alright, I will continue now by cutting rest of that stock and then we jump to the CNC. It took a bit more time and effort to get these cut files right, so it's now almost a week later. But now I'm going to cut the next test pieces from this plywood sheet that I bought and from all these scrap pieces are just lying around. This is 6.5 millimeter mixed plywood. It has a birch top and bottom, maybe a little bit too good material for this. The first cut we're going to make is dog holes for this one scrap piece there. I'm planning to make a workbench where we can put clamps and stuff on there. But very first thing I want to do is to grease these rails and racks and pinions and stuff here. And then I'm gonna test the orientation of this x-axis so I can make sure that it's perpendicular. So my pieces will have the correct form in them. So a bunch of things to do, but let's start with this now. This is too big, it doesn't fit between those rails and stuff, so it's bad. Okay, now I have calibrated the X movement and Y movement, and now it's time to configure the squareness of the machine. I have already done this a couple of months ago initially, but I now, when I have planed this surface, calibrated this, I do that again and we'll see if this is actually square. One thing is interesting, this doesn't really seem to have any backslash at all. All the back and forth movement, they go spot on at the right positions, so I don't think that's really a big deal with this machine. I'm really pleased with that.
So I'm using here the 3-4-5 method. This end is 4, this is 3, and this should be 5. And now I have moved the y-axis 800, this x-axis 400, and this should be now exactly 1 meter. And now we can check that this is right on this cross right there. A little bit hard to see. But now this is exactly right. So I think my machine is now very, very accurate and ready to use.
Alright, that took almost 2 hours. It was way too slow, but meanwhile I managed to do these, which are the clamps I'm gonna use with this board. So they should go into these dog holes like that and push things down. This seems to work very well. Next, I'm gonna run another program for this board. I'm gonna do smaller screw holes for attaching things between these dog holes. Hopefully this time the running speed will be much faster. Alright, that took maybe an hour, and now I have this workbench tabletop which has regular dog holes and also these smaller holes for attaching a little bigger screws into the plywood to hold things in place. So I think this board will be very much in use in future, but now I'm going to use it to make the second test piece and also test this system of the dog holes and stuff. And yeah, it looks quite good, and quick measurements taken here and there. Looks like it's very, very accurate. So the idea, of course, is that now I have this regular pattern of holes in this board, and with the computer I can design whatever shaped part and put these holes into that part to hold them just in the right spot on this board. So now I'll take this off and we'll do just that for the first piece. Really exciting. that was intense. I really needed to develop the hole down for this large pieces of plywood. I just put some two-sided tape. There should be plenty more of that or something else. And I need to make sure that the Fusion 360 makes these holding tabs for these parts. So in these there were maybe 3-4 of them. It almost got loose on that end, but I just hold them down by hand. But other than that, the result looks very good. They fit together perfectly. This is now real size test. It's a bit shortened version, of course, but the width and the thickness should be like the final frames will be. This is now 6.5 millimeters, so it's much stronger plywood than the previous test. But now it's getting a little late. I'm just now going to cut the spacer pieces from various scrap plywood pieces. I got almost everything cut yesterday, but, well, bit snapped, so I didn't have a spare one. So I had to come back today to finish these parts. So let's just change the bit to a new one and continue. Okay. So, I was just about to say that now everything works. Well, obviously the 2 millimeter tabs with this plywood is not enough, so this just came off and then it moved, and yeah, you can see the remains of the tip in there. So, oh well. Alrighty, bunch of things done with the CNC. I got somewhat of a pace using it. Everything becomes more familiar every time. And now here we have a bunch of stuff. If we start with these, obviously, these are the molds for the frames. And this system is now made such that I have this tabletop, and these parts with these holes fit on these holes like so. And all these parts are the spacers between these two. So this fits in that hole and goes in the corresponding hole in the table. And now all these holes here fit to these corresponding holes as well. I'll just show you with this. So like that. Now it's in place. You can imagine we have all these spacers in here. They're all in those holes, and then there's these smaller holes all for mounting screws. So I can screw these down into this table. So these packs and this bottom piece will be firmly against the table. And this top piece goes on like that. Looks familiar, doesn't it? And these are the dog hole clamps that will go in any of these holes in this table. So like that, for example. Then I just screw this down like so. And now it holds it down. and I have 5 of these. So the idea, of course, is to hold this thing down. Maybe I'll have some additional piece of wood to spread the load. But yeah, this is the idea. And everything looks very, very good. The machine works quite well. Only 2 bits were destroyed. And I have learned a bunch of things of this machine. So I think I'll end this video by going through what I would change with this CNC machine and what will I improve. So let's start with that electric cabinet. So this electric cabinet is awesome. It works very well. But what I will change is this VFD controller. It creates just too much of electric noise so that my sensors won't work. It will trigger the sensors even though there's nothing connected to them. It is a mistake to place this thing so closely to this CNC controller. So this I will take away from this cabinet and place it somewhere else. And also you have to have access to these buttons because every time you put on this thing you have to push the run button. That's one thing. But otherwise everything works very neatly with this. Then there is these rails and the carriages that should have grease on them. Now I don't have really good access to grease them all. So I have these nozzles back here, but the grease gun is too big, so it doesn't fit in there. So that's kind of a bummer. I have to take a look if I can find a smaller grease tool. That's one thing I have to do. So I would design it a bit differently if I knew this. Then there's another thing, and it's this spindle holder. It has a tiny bit of angle, so it is not completely straight. It's a bit off in this way, so you can probably see these markings in this spoil board. So in this way it is completely smooth, but in this way there is a bit of markings, or you can feel. So this thing should be more accurate. Now I really can't do much about that. I should have some kind of tool to measure the thing. Maybe we'll come back later to that issue. But something you have to keep in mind. Otherwise the accuracy looks very, very good. No issues whatsoever. And one big thing I would do differently if I would do this again is the basic structure. So this is steel, which is quite cheap material, but overall the budget went over by 50% maybe, because the machining of these steel parts was very, very time consuming and had to have a big machinery and stuff. So I would probably go with aluminum extrudes, even though they are more expensive, but overall I think they would be much more nice to handle and also modify. But yeah, this is done. This is very sturdy. It was very expensive. Now I have this and everything else is changeable. But I would do this differently now. And finally, some things that I have learned by making all these parts and some test pieces as well. The most important thing maybe is that I should make bigger tabs for holding the pieces in the piece holder thing. There were quite many occasions where the tab didn't hold up the piece in here, so it just came loose and well, one tip was lost because of that. And these last test pieces I made much bigger tabs and they hold perfectly. So that's one thing, make bigger tabs to really keep the pieces where they should be, so no wobbling around. And that brings to these pieces. Let me show you them a little closer. So I made a bunch of these pieces to test the tolerances needed for making joints. Here you can see there is 0.2. That means that there are 0.2 millimeters of tolerance between these parts. And let's start with the 0. So these 2 pieces, they have no tolerance on them whatsoever, and they fit together quite well. And if you take a little closer look, you can probably see that the cutting angle isn't actually completely 90 degrees. That might be from the cheap bit that I used to make these pieces, so maybe a little more expensive, a better tip would do a better job. Without tolerances, this piece fits together very, very well. But if I turn this around, now there is a just tiny bit of play. So that angle kind of goes, they compensate each other. So there's a bit of play. But in this way, they work very well. So I think this bit is an issue here. And that's one thing I'm gonna do very soon, to order really good quality bits. So far I have just done hardware store cheap bits. And if you take 0.1 millimeter, it's significantly more loose, so they just go through like that. And 0.2, it's even more loose. So at least with these bits that I have now, I can just make a form and don't have to worry about the tolerance between these kind of joints. So that was a good experiment. And what else? Oh yeah, the piece holding. So the biggest issue perhaps is how I hold the material on this table. So I don't have vacuum table. I have just now used double-sided tape and some screws. But the problem is that the plywood sheet is never exactly flat, so it tends to have some wobbling in them. You can see the issue with these kind of parts. There's a hole, but it is not completely through. So that means that when I measure the Z height from that corner, it was a bit higher than the actual place where this particular piece was. So yeah, maybe I should just go little deeper with the machine or something. But yeah, I'm kind of thinking if I should make a vacuum table of some sort, even for some part of this spoil board, but we'll see about that in the future. I just use now screws and double-sided tape. But alright, I think that's it for this video. Now I'm gonna pack all this in the car and bring them to my living room. And in the next video, we're going to laminate this full-scale frame test piece. So that's going to be very exciting. Feel free to leave a comment down below, give me a like, subscribe to the channel. The boat building process is really starting from here. And yeah, we'll see you hopefully soon. Bye!